Hello, in this video we're going to look at the effect of pension benefits on labor supply and retirement decisions. We're going to start with the case where there are no pension benefits. Sebastian is 60 years old and has 20 life years remaining that can be allocated to work or retirement. His annual salary is $40,000 per year and non-labor income is $200,000. Assume Sebastian works another 10 years. In a well-labeled diagram that uses a budget line and indifference curve, show Sebastian's utility maximizing number of years of retirement. The first thing we want to get is Sebastian's endowment point. That's going to be the point where he takes 20 years of retirement, and that will be $200,000, just as non-labor income. So 20 years of retirement, no working for 20 years, his endowment point will be $200,000. Let's calculate the vertical intercept of the budget line. The vertical intercept occurs when Sebastian does nothing but work. That is, he has 0 years of retirement. How much income will he have? Well, we start with the $200,000 of non-labor income, and then we get $40,000 per year over the next 20 years. That's $800,000 of income, so he would have a total of $1 million of income being generated. So the graph then would look something like this. So here's the endowment point. We got years of retirement here. So if he takes 20 years of retirement, he doesn't work anymore, and his amount of income will be just his non-labor income or $200,000. This is in millions, so this is 0.2, or like I said, $200,000. And the other key point here on the diagram is if he does nothing but work, 0 years of retirement or 20 years of working, that'll be $1 million. And we're told that he maximizes utility at 10 years of retirement. So that occurs right here in the middle. Drawing our indifference curve there, he would generate $600,000 of income. The $200,000 of non-labor income plus 10 years of work at $40,000 each. That would be $400,000 of labor income plus the $200,000 of non-labor income. That's where this $600,000 is coming from, or $0.6 million. Okay, moving on. With the pension benefit, Sebastian, same setup here, 60 years old, 20 years of life remaining that can be allocated between work and leisure, same salary, same non-labor income. Suppose Sebastian can receive a pension benefit now of $15,000 for each year of retirement. Let's graph Sebastian's new budget line. So the endowment point occurs here at 20 years of retirement. He has this $200,000 of non-labor income he starts with, plus 20 years of retirement. He'll draw a $15,000 pension for each year retirement, so $15,000 times 20 years of retirement. That's going to be $300,000 of income plus the $200,000. So our endowment point incurs at $500,000, $500,000. The vertical intercept means 0 years of retirement. He will not be collecting any pension here because he's going to work all 20 years, and so the vertical intercept is still $1 million. $40,000 a year over 20 years of working is $800,000 plus this original $200,000 of non-labor income. Let's take a look at the graph. Okay, so the new budget line here, I'm going to outline it with my mouse. Here we see our new endowment point here at $500,000. And then the budget line will then touch the vertical axis at the same $1 million as the old budget line. So the pension benefits causes the budget line to shift outwards but flatten out here a little bit. Okay, let's move on. Let's find the new utility maximizing choice of retirement years. Does Sebastian take more years of retirement because of the pension? So here I'm drawing a new indifference curve. Sebastian can get on a higher indifference curve, increases utility when he has access to this pension benefit. And he chooses a point right here at point B, which means more years of retirement or fewer years of working. So at point B, we've got 14 years of retirement times a pension benefit of $15,000 for each year retirement, plus he's working 6 years at $40,000 a year, plus the original $200,000 of non-labor income. So this point occurs at $650,000 or $0.65 million. Okay, moving on. Let's show the income and substitution effect of the pension benefit. So the income effect is going to be given by A to A prime, this movement here. How do I find it? I take the old budget line and I shift it out in a parallel fashion. And once it's tangent to our new indifference curve, that difference will reflect the income effect, the pure income effect of the pension benefit. So the pension allows Sebastian to demand more leisure, more retirement. Retirement increases from 10 to 12 years due to the income effect. So this point A here aligns with 12 years of retirement. In terms of the substitution effect of the pension benefit, that's going to be given by this movement from A prime to B. The opportunity cost of retirement has decreased because of the pension. Sebastian only gives up $25,000 a year from not working. So that's the $40,000 minus the $15,000 benefit. So he's really only sacrificing $25,000 a year from not working now. Without the pension benefit, Sebastian had to sacrifice $40,000 per year from not working. Because he's getting the pension benefit, he's now only sacrificing on that $25,000. So that's why the budget line flattens out. So the substitution effect here causes Sebastian to take 2 more years of retirement. So the total effect here is that years of retirement goes from 10 to now 14. Okay, I'll stop here.